Hey guys, it's me again. In this video, we'll see a very brilliant script that I found on the Salome website here. So what it actually does is it extrudes the mesh along its normal direction so as to create a solid mesh out of a surface mesh. So let me show you the script. The script is this one, mesh normal extrusion. So you can just download it from here. So this is the script. So basically it creates some geometry and then meshes it. In this case a half sphere. The original script creates a half sphere and then creates a surface mesh over it. And here another option is provided in which we can skip these steps of geometry and mesh creation and just direct import a med file. So the way I have used it is through this option. I have already got a med file and then I just uncomment it and give the path to my med file, and that we'll see just in a moment. And then it's just uh, computes the face normals and starts to create more geometry. And finally, here you can see the mesh that we provide and the normals that it computes through these functions here, and that is the distance that you want to offset along the normal. Okay, so this is the original script. Let's see the edited script. So okay, so this is my edited script and the med file for this is here. So here I got a simple planar mesh, all quadrangles, and I just want to offset them in the opposite direction of normal by some value, and I want two layers there. So let's just see the script. So this is the path that I have provided in the med file. You can easily set this path and create you can create your own directory and set this path here, and then this is my value. So I just want to offset it by 150 mm. I want two layers out of it. This is the first layer and here goes the second layer. So let's see what happens. So to do it is very simple. I'm gonna go and say load script and then select my script and it's executed. So let's just see the mesh. So it's just extruding it in the opposite direction of my normals, and I've got two layers over here. And this actually is is an alter is a it's to circumvent a problem that we get when we try to do the same operation through this command. You go to transformation and say offset. The problem here is that this command does not support quadrangles, it only supports triangles. So this script comes to our rescue. And okay, this was a very simple example. Now let's move on to a more complex example. So here you see an impeller, and I have done some work over here to extract these impeller surfaces which are very curvaceous and are very important for the proper functioning. So this is one of the faces that I've extracted, and so I just created a mesh over here, and you can easily create this mesh using the quadrangle rules. inside of Salome, and we want to offset it to provide a thickness to the impeller surfaces. So you see here we need to cover this thickness, and the thickness all the way around the base surface is constant, so the impeller always has a constant thickness. And again we can use the script, it's very helpful in this case. Let me show you. So let's just close it, and what I'm gonna do is load script, and that's just 3D extrude. So again this script has been executed, and I'll just show you the final result. And as you can see, due to some changes made in the script, it has even been able to do it in 3D and correctly pick the normals in 3D. Of course, some work needs to be done here to shift these nodes so as to match with the geometry. But you can see most of the work is done here. So let me show you the script for this file. So this is my script, and it's exactly the same as previous one. The only thing I've changed is the path location for med file, as well as some changes in the value of the thickness here. So it's like 1.5 mm. I needed two layers of 1.5 mm here. So that's how I got my uh, hexaedral mesh, all hexas, and perfectly offsetted just the way I need it. So I hope this was helpful to you. Thanks for watching.